Alright, let's continue on. So I have that f of x is equal to negative 2 times x minus 3 squared minus 5. Alright? Well, this is an x squared, which means my basic shape looks like this. It's got key points to the left and the right. So, let's keep going. Vertical shift, do I have one? Yep, minus 5 means I go down 5 units. Do I have a horizontal shift? Yes, I do. A minus 3 means I need to move right 3 units. The vertex, given this information, remember it's going to be opposite that, so positive 3, negative 5. Plot your vertex. There we are. Compression stretch, do I have one? I do. It's negative 2, which means that my graph is actually going to be pointed down because it reflects. So I need to go down 2 units from that vertex. So from my vertex, I go down 2 units, over 1 to the left, down 2 units, over 1 to the right. Find your x-intercepts. Same thing, set the function equal to 0, solve it for x. So negative 2 times x minus 3 squared equals 5. Divide by negative 2, and you get x minus 3 squared is equal to negative 5 halves. Take the square root of both sides, and you get that x minus 3 is equal to plus or minus I square roots of 5 halves. If I move up here, x is equal to 3 plus or minus I root 5 halves, but it makes me imaginary, so I don't have x-intercepts. Just finish off. Make sure you have the same basic shape as your parabola. You do. And you're all done. Makes sense I don't have x-intercepts because I don't cross the x-axis. Alright, example 6. Let's finally look at something a little different. So I have 1/2 times the square root of x minus 3 plus 3. So finally something different. It's the square root of x. That is the half of a sideways parabola, and it's got one key point. Do I have a vertical shift for this function? Plus 3 means I go up 3. Do I have a horizontal shift for this function? Yep, there's a number underneath that radical, so that's a minus 3. I know that's opposite, so minus 3 moves me right 3. What's the new vertex for this? Well, the new vertex, opposite of a negative 3, would be a positive 3, and then positive 3. So the new vertex for this function is right 3, and then up 1, 2, 3. Right there. Compression stretch. Do I have one? Am I multiplying the function by something? I am. I'm multiplying the function by a half. So my compression stretch is 1/2. That means that I need to go up, because it's positive, right? I need to go up 1/2 units, or half a unit. So from this vertex that we found, I go up half and over 1. Notice you always go up whatever this is, or down, right, if it's negative, and then always over 1. Always over 1. So I have to go up a half over 1. X-intercepts, I set 1/2 times the square root of x minus 3 plus 3 equal to 0. Let's solve this for x. So 1/2 times the square root of x minus 3 is equal to negative 3. Multiply both sides by 2 to clear your fraction, and you get the square root of x minus 3 is equal to negative 6. If I square both sides, I get that x minus 3 is equal to positive 36. Solving for x, I get that x is equal to 39. Alright, but this is a square root function, and I know that I need to check those, so let's check x equal 39. Well, if I plug it in, 1/2 times the square root of 39 minus 3 plus 3, is that actually going to give me 0, right? Because we have to go back into this one. Well, let's see, I don't know. Half of, 39 minus 3 is 36 plus 3, is this going to give me 0? Half of the square root is 36. The half of the square root of 36, so the square root of 36 is 6. So half of 6 plus 3, does that give me 0? Half of 6 is 3. Does 3 plus 3 give me 0? No. So I had to discard this answer. It was extraneous. So the answer is none. I do not have an answer, so I don't have an x-intercept. Let's go ahead and graph this. Remember, it has to look like half of a sideways parabola, just like that. And notice, this doesn't go on this way, so I'm never going to cross this x-axis. Again, it makes sense that I don't have an x-intercept. Let's look at a couple more here. I have f of x is equal to negative x minus 3 cubed plus 1. This is an x cubed function, and that one kind of looks like that stretched out n. And it has key points in the opposite direction. One goes up and right, the other one goes down and left. Vertical shift. Do I have a vertical shift? I do. I'm adding 1 to the function. Makes it go up 1. Do I have a horizontal shift? I do. -3. Remember, it's opposite what we think, so a minus moves us right 3. So the new vertex for this guy, +3, +1. Plot your vertex right there. Next, do I have a compression stretch? Is there a number out there? There's a negative, so I can write -1. I have to think that I have to reflect this. Alright, well, how do I reflect that? Remember, I said that it has to be reflected about the x-axis, right? So here's my x-axis. So if I exist like this up here, then I need to exist the opposite way on the bottom. So if I exist down here on the left, then I have to exist on top on the left. So I'm actually just going to look like this. I'm going to look opposite what I'm used to. Key points here are opposite, so I'm going to have to go down, and if I look here, I'm going to have to go down and right 1. And then what's the complete opposite of down and right? That's going to be up and left. Remember, with the key points for the cubes, the cube and the cube root, it's completely opposite. One way and then the other way. If you look here, when we drew this, right, when we drew it reflected, we see that we're going to have to go down and right, and then we're going to have to go from the vertex up and left. So you have to do the complete opposite with these cubes. X-intercepts. All right, let's see if we have any x-intercepts this time. So negative times x minus 3 cubed plus 1 equals 0. Subtract 1 from both sides, and you get the negative of x minus 3 cubed is equal to -1. Divide out my negative here, and I get that x minus 3 cubed is equal to a +1. Right? I need to undo a cube, so I can take the cube root of both sides. That's going to give me x minus 3 is equal to, well, the cubed root of 1 is just 1. Add 3 to both sides, and x is equal to 4. Now cubes, I don't have to check. So then, yay, I finally have a true x-intercept. So here we go, we have an x-intercept of 4. Ooh, and we actually forgot to do our key points. So let's go actually back and do that. So we had said that our compression stretch was -1. So from the vertex, I need to go, it said down and right 1. Then I have to go back to that vertex, and I need to go up and left 1 there. So those are my key points. Now, my x-intercept we said was 4. 1, 2, 3, 4. Woo, I already graphed that. Great. So now just make sure it's got the same shape as your basic shape, which is kind of like that stretched out end. Well, backwards end at this point because we're reflected. And we're done. All right, the next video is just going to have 3 more examples of this.